Imagine a wall of water, a liquid mountain moving with impossible speed across the open ocean. It is taller than a 10-story building, a skyscraper of pure, raw energy. It rises from a seemingly calm sea, defying all expectations of the surrounding waters. It appears almost instantly with no warning. It is utterly alone, a solitary monster in a vast expanse. This is not like the rhythmic waves you see at the beach, predictable and gentle. This is something else entirely, a freak of nature. It is a rogue wave. Scientists have confirmed they can reach a staggering 30 meters in height. This colossal force of nature can break massive ships in two. It can erase a lifetime of work in a single, devastating moment. It is the ocean's ultimate, unpredictable display of power. A rogue wave is defined by its sheer unexpectedness. It is a wave that is more than twice the size of the significant wave height around it. The significant wave height is the average of the highest one-third of waves in a given area. It's the standard measure mariners use to understand the sea state. So, if the sea is filled with waves of around 5 meters, a rogue wave would suddenly appear at 10 meters or more. For sailors, this is the stuff of nightmares, a legend turned terrifying reality. One moment, the ocean is manageable, predictable. The next, a vertical cliff of dark water is bearing down upon them, appearing from nowhere to swallow the horizon whole. They were considered myths, tall tales told by shaken mariners. Scientists were skeptical. The mathematical models of the ocean did not seem to allow for such singular, monstrous events. But the stories persisted. Experienced sailors from every corner of the globe spoke of holes in the sea followed by a mountain of water. They described waves that came from a different direction than the wind and the prevailing swell. We now know these sailors were telling the truth. The ocean was simply hiding its most terrifying secret in plain sight. These waves are not tsunamis. A tsunami is a different beast, born from a tectonic shift deep beneath the ocean floor. It is a displacement of a massive volume of water that travels across entire oceans. A rogue wave, however, is a surface phenomenon. It is born from the chaotic energy of the sea itself. It is localized, fleeting, intensely powerful. It is the ocean's own breath, concentrated into one gigantic, godlike exhalation. How can a single wave grow to such a terrifying height? The process is not a single, simple mechanism. It is a combination of factors. A perfect storm of oceanic forces. One of the primary drivers is constructive interference, wave focusing. Smaller wave patterns combine into a single peak. The open ocean is a complex surface. Waves of different sizes. Waves of different speeds. Waves traveling in many directions. Occasionally, crests of several smaller waves align perfectly. Their energies combine at one specific location and one specific time. That fusion creates a much larger wave appearing from almost nothing. Strong, persistent winds also play a crucial role. Wind blowing over a long stretch of water transfers huge energy to the sea surface. That energy builds larger and larger waves. When that swell meets an ocean current moving opposite, the effect is magnified. The current acts like a brake. Waves slow down. The shape of the ocean floor can contribute too, especially near coasts. Waves moving from deep to shallow compress energy and grow taller. Underwater ridges or seamounts refract and focus wave energy like a lens. This creates hot spots where huge waves are more likely. All these factors, wave focusing, wind, opposing currents, can sync up, creating the ideal conditions for a 30-meter monster. Storm systems are the ultimate rogue wave factories. A hurricane, a severe North Atlantic storm. Waves crash into each other from all directions. The wind is relentless. Currents are turbulent. Multiple wave trains meet at the perfect angle. The energy is already high. The sea is primed for an extreme event. In these violent conditions, the ocean can gather its strength and forge a single, solitary wave of godly proportions. Then, on January 1st, 1995, in a moment that would forever alter our understanding of the ocean, everything changed. In the harsh environment of the North Sea, an oil platform named the Draupner was being battered by a fierce storm. The platform was an engineering marvel, designed to withstand incredible forces. Crucially, it was also equipped with state-of-the-art sensors to measure the conditions. That day, the significant wave height was measured at around 12 meters. The crew was prepared for a rough ride, but nothing out of the ordinary for this unforgiving sea. But they were not prepared for what came next. A single, colossal wave slammed into the platform. The laser-based sensor on the platform recorded the event with undeniable precision. The instrument graph spiked dramatically, capturing a moment that defied all expectations. The wave that struck the Draupner platform measured an astonishing 25.6 meters from trough to crest. It was more than double the height of the surrounding waves, a perfect, terrifying example of a rogue wave. It caused only minor damage to the platform, but its true impact was on science. This was the first time a rogue wave had been digitally measured, providing the concrete, irrefutable proof that scientists needed. The sailors' myths, dismissed for centuries as tall tales, were now scientific fact. The Draupner wave became a landmark event in oceanography. This single piece of data forced a complete reevaluation of how we understand ocean dynamics. The old models, which predicted such an event would occur only once every 10,000 years, were clearly incomplete. The Draupner measurement spurred a new wave of research using satellite data, radar systems, and advanced computer simulations to hunt for these ocean giants. Beyond the cold, hard data and the abstract physics lies the human story, a story of courage, terror, and profound respect for the power of the deep. For those who work on the sea, a rogue wave is not an abstract concept. It is a terrifying, life-altering reality that can arise from an otherwise ordinary day. Imagine being a sailor on the deck of a container ship, part of a crew navigating the vast expanse. The weather is rough but manageable, the rhythm of the waves a familiar, if unsettling, companion. Suddenly the ship drops into an impossibly deep trough, a hole in the sea. For a moment there is an eerie, weightless silence. Then you look up and see a near vertical wall of black water blotting out the sky, a liquid mountain moving with impossible speed. There is no time to run, no time to prepare, only the deafening roar and the crushing impact. Survivors speak of the sheer, unimaginable violence of the event. It is not like being hit by a normal wave. It is like a collision with a solid object. Steel designed to withstand immense forces bends and tears like paper. Bridge windows rated for extreme pressure are shattered inward. Water floods critical compartments in an instant, shorting out electronics and plunging the ship into a terrifying darkness. People are thrown across rooms with bone-breaking force. Those on deck can be swept into the churning, freezing ocean in the blink of an eye, their fate sealed by a single, unpredictable movement of the sea. For those who survive, the psychological toll is just as profound. A sailor might spend weeks at sea, their ship a small, self-contained world of order and routine. The rogue wave shatters that world, replacing a sense of mastery with a stark reminder of who is truly in command.